So P5 is about factoring polynomials. So what's the difference between a factor and a multiple? Well, let's look at something simple like 10 divided by 2. If we take 10 divided by 2, we get 5, the whole number 5, which tells us that 2 is a factor of 10 and 5 is a factor of 10. You did these in elementary school. These are fact families. So another word that we could use for factor is a divisor, which of course is indicating that you do need to divide. Now, we've used factor trees quite a bit. Let's go 450, which would be 45 times 10, which would be 9 times 5 times 2 times 5. Would you stop there? Probably not. Why not? Because 9 is not factored completely. That's a phrase we're going to have to pay very special attention to in this chapter. So we talked about in a previous section the prime power factorization. So the prime power factorization of 450 would be 2 to the first times 3 squared times 5 squared. So in order to get a factor, we need to divide. The flip side, multiples. Obviously, multiples of 10. 10 times 1, 10 times 2, 10 times 3, 10 times 4. Multiples are infinite. Integral multiples go on to infinity. Factors have a limited number. If we look at just the number 45, that's something that we can easily manage those factors. And I'll write them in a roster notation here. 1, 45, not divisible by 2, 3 times 15, and then not divisible by 4. 5 times 9, not divisible by 6, not divisible by 7, not divisible by 8. We're done. So factors have a finite amount. Multiples have an infinite amount. So that's the biggest differences between factors and multiples. So we're going to just quickly, in this very short video, list the factoring strategies that we're going to cover in this section. So the first thing we're going to look for, and we're going to look for this every single time, first thing, the biggest reason is that it makes the numbers smaller. We are going to look for a greatest common factor. And basically, if we're looking for the GCF, we're looking to undo the distributive property. That's the easiest way to think about the factoring out a greatest common factor. We're just undoing the distributive property. That's essentially what's happening. Second, we're going to look for if we have the difference of two squares. I call that the DOTS. Very easy to spot. Obviously, it's a difference, which is implying that you're going to have subtraction. And if there's only two terms, it's going to be a binomial. And then, of course, those two terms would be perfect squares. So we're going to be on the lookout for the DOTS, the difference of two squares. Maybe we're going to have to factor by grouping. And the only time you factor by grouping is when you have 4 or more terms. Only when you have a polynomial with 4 or more terms. And then everyone's super favorite, the guess and check. And notice it doesn't say guess or check, it says guess and check. The check is imperative. It is critical. You have to do it. It's required. And then this year, we're going to learn about something that maybe some of you did not get to in your previous class. We are going to learn about the sum or difference of two cubes, perfect cubes. So, sum or difference of cubes, which I gave a little hint at in a previous video. So these are the 5 factoring strategies. So please be sure to write those down, and we're going to have a video for each of these strategies following.